of the project ZeroTrustVC. This web page here emulates a cloud-based storage system. Let's try to access the contents of the root folder. As you can see, access is denied. Let's try to receive a verifiable credential that will give us access to the contents of this folder. So, this is the home page of our verifiable credential issuer. In the issuer, we have defined a number of endpoints, and this endpoint here represents our cloud storage system. Each endpoint is configured with a number of resources. For example, the cloud storage system is configured with the folder resources and the file resources. And each resource is associated with a number of operations. For example, the folders resource is associated with the list operation, whereas the files resource is associated with the read, create, and delete operation. Then, in the clients section, we define our wallets. For each wallet, we create an identifier and a secret. Finally, let's add some authorizations to our wallet. I will add all authorizations related to the cloud storage. As you can see, all authorizations have now been added to my wallet. So let's request a verifiable credential. I will add the URL of the issuer, the wallet ID, and the wallet secret. And now I have received the credential. Let's see what happened behind the scenes. I will interact with a verifiable credential issuer using a command line based wallet, and this is the response I'm getting. This is a verifiable credential encoded as a JSON Web Token signed using JSON Web Signature. Let's see the contents of this token. So, when I request a verifiable credential from the issuer, I have the option to create a public-secret key pair and ask for the issuer to include the public key in the verifiable credential. So, this is the public key I have created. Alternatively, I can ask the issuer to include a decentralized identifier. This is the verifiable credential identifier. This is the audience of the verifiable credential, which is our cloud-based storage system, the creation time, the expiration time, and these are the actual contents of the verifiable credential. As you can see, these are the resources and these are the allied operations. And this credential also includes information that can be used for verifying its revocation status. So, let's try to access again the contents of the root folder. As you can see, now I can see the contents of the root folder. So, let's see what happened. I will refresh the page. And now, this is the actual HTTP request. What happened is that our VC wallet injects two HTTP headers. The first header is the authorization header, which includes the verifiable credential we received with the previous step. The second header is the depop header. The depop header is a JSON Web Signature that has been generated with the private key that corresponds to the public key included in the verifiable credential. Therefore, using this public key, a verifier can verify the signature here. Therefore, the proof of possession of verifiable credential can be verified. Now, let's go back to our verifiable credential issuer. And this is the credential we just issued. You can see here the content of the actual credential. Now let's revoke this credential. Yes. And I will try to access again the contents of the root folder. You can see here that access is denied because the verifiable credential has been revoked. So what happened? You can see here that the verifiable credential includes this URL. Now, the verifier can receive from this URL a revocation list, and at the position 8 of this revocation list, the status of this credential is included, which in this case is revoked. Therefore, access is denied.